Okay, so we have that the null hypothesis of independence of two classifications, A and B, as shown on the 3 by 3 contingency table, was rejected at the alpha equal to 0.10 level of significance with the chi-square value to be 10.542 and our p-value of 0.0322. And we have a table. Now, before I explain it, so I have something about A's and B's, okay? So these are two things that I'm testing, A and B. And then B, as you guys can see, could happen 3 times, like B1, B2, B3. So there are things that I'm testing. For example, one thing I could ask is for people to come to a school site, how do you get here? Do you get here walking? So there's a choice. Do you get here walking? Do you get here in the school bus? That's a second choice. Or do you get here in a personal car, your family car, they bring you over? All right, so see how there's certain things I could be asking that has more than one choice. And then so that's my variable B. I'm not saying I'm really testing on how do you get here to school. I'm just saying I'm testing on something that I could have 3 values. And then A is something else, another variable that I'm checking, and it also has 3 values. Instead of coming out with what to test and figuring out a test and just worry about the variables, I'm just going to call in variables A and B just to come and say, I'm not really interested in the variable. I'm more interested in the results. So again, I'm going to call in variables A and B. For A, we're going to see A1, A2, A3. And for B, we're going to see B1, B2, B3. Okay. And then A1, B1, the way we're going to read this, A1, B1, we have 42. A2, B1, we have this 65 values, and so on and so forth. So let's see. Convert the responses to percentages by calculating the percentage of each B class totally falling into each A classification. All right, what I'm going to be doing first, let me use Excel. And I'm going to copy our table, our values here, the 9 values that I have, these 9 values. So let me grab an Excel spreadsheet, and I'm just going to calculate our 3 values. Let me write them down. We had 42, 64, 45. Again, I'm just going to copy the 9 values as they are on our table. So let me just see, there's a 73, 34, 35, and 28. For us to be able to see, let me highlight this in yellow. So those are the 9 numbers that we have on our table. Now here on D, on this column D, let me just click equals. So I'm gonna do an operation and I'm gonna add my first row. So this is what we call a row. Row goes sideways. So you see I have row 1, row 2, row 3. These are rows. So I'm going to add all of row 1. So I'm going to do sum, open parentheses, and I can click this one plus this one plus this square. Okay, so all of those are 151. Let me actually drag these. Excel knows that I'm adding each row, and then they double check. This one, I double click it and it adds this row. Okay, I just want to know here the sum of my rows. I added my rows. Now here at the bottom, I'm going to add my columns. So I'm going to add my A column. So I'm going to go and I'm going to tell the equals the first space plus, oops, plus this one plus the third space. And a typo in your, oh, I see. I had an extra parentheses there. So, okay. So I added my values here. So it said it added all my rows. And then I'm just going to go here. I'm going to drag it. And then it adds my rows. As a matter of fact, I want to even continue this. So now one thing. 141 is if I add my row A. which according to our table was the B1. 149 if I add my row B2 from our table. And then this 146 is if I add my row, my column B3. Now this 436 is if I add them all. So if I added everything, I'm going to need it. So let me come back to my notes here. So I just copied so far, I copied the table, and then I added the totals on each end. Now convert the responses to percentages by calculating the percentage of each class total falling into each A classification. Okay, so this is what we're gonna do. Let me do a table here. So I'm gonna have a table of B, and I'm gonna say there's my column B1, my column B2, and my column B3. But then I also have my variable A, and I'm gonna have my row A1, my row A2, and my row A3. What I'm going to do for this first space, because it says convert the responses to percentage by calculating the percentages of the B class. So in reality, what I'm looking at, these three variables, because it's a B class, so B1, I want to know so I'm looking at these variables, what are the percentages of each? So in reality, I want to know, okay, for the first one, it was 42 divided by, how many are there all together? I know earlier I added them all and I found out that it was 141 altogether. My whole column was 141. Now 42 divided by 141, use a calculator necessary. It's going to give me a decimal rounded up to the nearest percent. So when I do this as a calculator, so let me do this at the side here. 42 divided by 141, it gives me 0.2978 and some more. I know that I have to do percentage. Usually when we do percentage, because percent means for every 100, we multiply this by 100, right? To convert this to percent, I multiply this by 100. I know some teachers said, just move the decimal twice to the right. Well, that is what happens when we multiply by 100. So it's going to give me 29.78%, because I'm looking at percentages. Now 29.78, my instructions said round to the nearest percent as needed. Okay, so what that means is rounded to the nearest whole number. Now 29.78 rounded to the nearest whole number, this becomes 30%. Okay, so for the second one, like I said, I'm just looking at the first column. For the second column, so for A2B1, so basically I'm looking at this space. I know my graph, I had 65. I'm going to divide this by 141. 65 divided by 141 gives me 0.4609. Multiply this by 100 to convert this to a percentage, and gives me 46.09%. So I'm going to call this 46%. Some of you guys might be wondering, oh my God, am I really going to have to do a lot of work for this table? Guess what? We're going to go to Excel instead. Here it is what I'm going to do. I'm going to go the first squared, divided by 141. I'm going to go this second squared, so equals the one divided by 141. And then this third one divided by 141. Remember, Excel, it's a calculator. Now I know I have to multiply this by 100. Oh, and actually in the second one, let me just do them all. So I'm gonna go 64 divided by 149. Now I'm doing it by the second one here. 50 divided by 149. And then lastly, 35 divided by 149. And then 45 divided by this one. I'm looking at the row 73 divided by 146. Now you guys might be wondering, oh, okay, at the beginning you guys were wondering, why am I getting the totals at the end? This is really why. Now, one thing you can remember to multiply this by 100, right? Move the decimal twice to the right. I'm actually going to go here and I'm going to highlight them and press percent. Now, the beauty of this actually rounds it to the nearest whole number. You guys see what I did? I just went, I highlighted those, and I click on the percent. Let me undo what I just did, right? First, it was this decimals. I know how to multiply by 100, so move it twice to the right. Don't forget to round to the nearest whole number. Well, I just highlighted those and press percent here. It rounds it automatically. It rounds it to the nearest whole number. So this thing right here, these are my answers. These are my answers for my table. So let me come back here. So I have 30%, 46%, 24%, 43% here, 34%, 23%. Because I'm copying the tables that we just got from our Excel spreadsheet. So this is 31%, this is 50%, and 19%. On your homework, you're going to see the percentages already. So you're going to see the table. You're just going to see the spaces for the numbers. But notice I'm rounding it to the nearest whole number. Before I continue, some of you might be wondering, I know this should be 100%. A whole row or a whole column should be 100%. However, when I add this, 30 plus 43 plus 31 is not 100, it's 104. Well, we were not looking at percentages by row. We were looking percentages as column. So I'm looking at my percentages here because it said of each class B. If I was looking at each class A, that's a whole different thing. Then I would be looking at rows. But because here it says each class B, then I was looking by columns. Each of this should add up to 100%. Sometimes it might add up to 99% or 101%, something not 100, but pretty close because of the rounding. So this is it. So, okay, so that was not that hard. Let's take a look at this other part here. Calculate the percentage of the total number of responses that constitute each of the classification totals. Okay, so I'm going to have basically our A1, all of my A1s, all of my A2s, and all of my A3s because of each of the A classifications. So A1, A2, A3. Now, what I'm going to do, and then I'm only going to ask you guys for 3 percentages. For my A1 total, basically, I want to add all of my A1s. So from my table, I want to add all of my A1s divided by how many there are altogether. So let me see. For my A1 percentage, I want to add all of my A1s divided by what's the total of my table. For my A2 percentages, I'm going to add all of my A2s divided by what's the total of the table. And for my A3 percentages, I'm going to add all of my A3s divided by the whole total. Okay, so You guys might be wondering, Mr. Leonzo, how are you going to do this in Excel? Let's go. Excel is pretty cool. Remember 151? That's when I added all of my A1s. So I have the sum of all of my A1s. I have the sum of all my A2s. I have the sum of all my A3s. 436, remember I called it earlier, our total of the whole table. So for this thing, I'm just gonna go, let me press equal sign here. And I'm gonna say, okay, so let me go 151, because that's all of my A1s divided by 436. Okay, so all of my A1s divided by my whole total, and it gives me 0.34633. I know I have to multiply by 100, round it to the nearest whole number. Now here I'm gonna go all of my A2s divided by my total. And lastly, all of my A3s divided by the whole total. Again, multiply each by 100, round it to the nearest whole number. I'm actually going to have Excel figure it out. It tells me my percentages are 35%, 43%, and 22%. So we said this is 35%, this is 43%, and this is 22%. Now we're going to create a bar graph row with row A1. So I'm just looking at A1. Okay. And percentage on the vertical axis on B classification on the total axis. Does the graph support the result of this test of hypothesis? So what I'm saying is I'm going to have a table. Well, let me do this in black. I'm going to have a table here. And this is going to be my A1 percentages on the vertical axis, because that's what it said here. A1 percentage on the vertical axis. Now on the horizontal axis, we're going to have B classification on the horizontal axis. So that means I'm going to have a B1, B2, and B3. All right, let me calculate my percentages to begin with. For my B1, since I'm looking at A1 percentages, I'm going to say, okay, so take a look at the table. Exactly what I'm looking. I'm looking at A1 percentages. I'm looking at my data from A1. Interesting that each of A1 had my A1 values. So like I said, when I'm looking at my row A1, there's a B1 value, a B2 value, and a B3 value. So for each of those percentages, I need to know how much they all add up to. And I remembered I did that through Excel earlier, and I found out that all of this, they add up to 151. Right, like I said, you guys can go to our Excel spreadsheet. They do add up to 151. So what I'm going to be doing is for my percentages, like looking at my A1 percentages, I'm going to go for the first one, 42 divided by 151. For the second one, 64 divided by 151. And for the third one, 45 divided by 151. So again, for my first one, I'm going to go from our values, 42 divided by 151. For my B2 value, I'm going to go 64 divided by 151. And for my B3 percentage, I'm going to go 45 divided by 151. You guys can see on our table where I'm getting the values 42, 64, 45. Right, I'm looking at the A1 row. Now the 151 is basically the sum of all of those. So let me find out my percentages. I'm gonna use Excel. So let me do my Excel spreadsheet here. So I have to go 42 divided by 151. For my second value, I have to go 64 divided by 151. And then on my third value, I'm gonna go 45 divided by 151. Gives it to me as a decimal. I can always multiply by 100, round it to nearest whole number, or I'm just gonna ask Excel to do it. So it gives me my percentages to be 28, 42, and 30. Okay. So let me come back to my table here. So I'm gonna say, let me count this by fives. So this is 10%. Well, actually, let me count by 20s instead. This is 20%. Yeah, I'm counting by tens. I mean, so there's 10, 20, 30, 40%, 50, 60%, and I don't need any more. From my percentages, I remember it was 28, 42, 30. So I have to go here up to 28%. I know on the second bar, I have to go to 42%. And this, I have to go to 30%. All right, so in the first one, 28%. Okay, let me emphasize that this right here, it is 30. So 28%, I'm gonna do a bar that is just a little bit less than that. My B2%, I have to go to 42, right? So I see where 40 is. 40 is about here. I'm gonna say just a little bit more. My B3, I have to go to 30%. So that's about here. Okay, those are my tables. Those are my tables. It said create a bar graph. Now, in your case, you might be wondering, oh my, how am I gonna graph this? Well, I'm gonna give you choices. So you should know how big is how big are your bars. You guys can do those on paper. Notice how I came in, I drew them. But then I'm gonna give you choices. You guys tell me which one is the one close to yours. Now, let me read. There's still a question here at the end. Does the graph, so looking at the graph, does the graph support the result of the test hypotheses? Now, the test hypothesis basically was the percentages are going to be different. My bars are going to be different. Now, we talked about before of a difference and significant difference. Remember how last week we were talking about significant difference. Let's say you guys asked me, just to remind you guys what we did last week. Let's say one of you guys asked me, Mr. Leon, so I think I have a 75% of your class. What is it? And then I come over and I said, oh, you don't have a 75%. You actually have a 74%. Pretty close, right? There is a difference. You thought it was 75 and in reality 74. There is a difference, but they're pretty close. So that's not a significant difference. But then what if you were asking, well, Mr. Leonzo, I think I have a 75%. And then I look and I'm like, no, you have an 87%. Okay, now that's a big difference, right? You were expecting 75, but no, in reality, it's 87. So now that is a big difference. That is what we call significant difference. So we know the bars are going to be pretty close. Or at least we expect them to be different. But now my question here is, are they really different or they're not really different? Now I see one is pretty tall, the other one's pretty short. So I'm gonna say yes, they pretty much are different. So yes, because there appears, I'm gonna say because there appears to be a significant difference, in the row A1 percentage. Now, this thing right here, there's some words that you guys might misspell. I don't want to risk in marking you guys wrong because you misspell something, right? Notice how different, for example, it's a word that has two Fs. Some people might spell it with just one F. Sometimes you guys might put extra spaces in between words. I don't want it to mark it wrong. I don't want the homework to be marked wrong just because you typed it wrong. You have a good idea. So what I'm going to be doing is I'm going to give you choices on what the answer should say. Now, one thing, my A1, I couldn't type in my A with my 1 here at the bottom. So probably you guys are going to see it as A and a big 1. So A1. It's just that I couldn't type it. When I was typing, I couldn't do A subscript of 1. So I just called it A1. Okay, so if you guys see it, that's basically what I meant. It's just on my typing, okay? Now, on each of your homeworks, I'm just going to ask you guys for a bar, and I'm going to ask you guys to tell me whether the graph supports the result of the test hypotheses. In my case, for my example, let me do 2 bars. Okay, so now here we're going to create a bar graph with row A3 percentage. So on the vertical axis, so I'm going to do a bar now again. And now here on the vertical axis, I'm going to have my A3 percentage. And the B classification on the horizontal axis. So I'm going to do B1, B2, and B3. And then I'm going to ask you, does the graph support the result of the test of the hypotheses? So I'm going to do some bars here. So what I'm going to be doing here, I'm looking at my A3 percentages, okay? A3 percentages. So what I'm going to be looking, so on the table, I'm looking at my A3 values. Each of those numbers divided by how much is the total. So let me do that on my Excel spreadsheet. Remember, I'm looking at my A3 value, so it's 34 divided by 97. Then I have 35 divided by 97. And then I have 28 divided by 97. These decimals, I can multiply by 100, round it to the nearest whole number, or I can just ask Excel to do it, highlight them, press percentage, and it gives me my percentages to be 35, 36, 29. So let me come back here. So my B1 has to go up to 35%. My B2 has to go up to 36%. My B3 has to go up to 29%. Okay, so here I'm gonna go, this is 10%, this is 20%, this is 30%, this is 40%. Let's say this is 50 and this is 60. I have enough. So my B1, I have to go up to 35%. So that's about here. My B2, I have to go to 36%. And my B3, I have to go to 29%. That's a little less than 30. Now, remember how in my previous one, you could tell the difference on the bars, right? Could tell one was pretty tall, the other one. Don't look at the width, right? Don't look at whether they're chunky or skinny. look at the height. I'm comparing the heights. Okay, they pretty much look the same. So does the graph support the results of that test hypothesis? Remember that the hypothesis at the beginning, I told you it was rejected, which meant the percentages are different. They're off. Now here, do you see a significant difference? I know B3 is the shortest and B2 is the tallest, but they're pretty close, right? They're not that off. So I'm gonna say no. In this case, no. Because my bars seem to be pretty close. Because the reason why I say no, because there does not appear to be a significant difference in the row A3 percentages. Again, I can do A, the subscript 3, but the way you guys will see it on your work will be something like A3. Because I couldn't do A in the subscript 3. It didn't let me. Okay, but in reality, what I mean is A3 percentages. Okay, so this is what I mean. I can write it. So notice one thing. From this question, when I ask you for the graphs, they were both B1, B2, B3 on the horizontal axis, all right? The B classification. Now on the vertical axis, I asked you for the percentages of A1. In one of my examples, I did A1. Another example, I did A3 values, and I could have done A2 if I wanted to, right? I could have chosen A1, A2, A3. On your homework, I'll be just choosing one of them, but I'll be choosing one of the three. So either A1, A2, or A3. So notice how I did two examples. You guys will do one per question. You guys will do your graphs. If you see a significant difference, then yeah, the graph does support the negation of the study. If you see a significant difference, so yes. If you don't see a significant difference, then no is not supported. Okay. Now we got that. Now let's flip the page. Let's flip the page. Let's take a look at a question like this. Newspapers lose their credibility when they found to have published deceptive or misleading news stories. Researchers investigated whether certain national stereotypes occurred more often in deceptive stories than in authentic stories. The researchers analyzed, in this case, 178 news stories that were proven to be deceptive in nature and 138 news stories that were considered authentic. Specifically, the researchers determined whether each story was negative, neutral, positive in tone. The accompanying table at the right gives us the number of news stories found in each category. So let me stop reading here. So there were some stories that were authentic, and there were some stories that were deceptive. The negative tone, 65 from those that had a negative tone, 65 stories were authentic, 116 were deceptive. Then there was a neutral tone, 48 were authentic, 55 were deceptive, so on and so forth. Okay, so now we know what the table here tells us. 138 means there were 138 authentic stories, and 178 means there were 178 deceptive stories. Okay, now let me continue reading this here. And the printout below gives a technology output for the data. The tables that I asked you guys to work with last week, remember, this is it. Now 65 and 116, that comes from our table, the table that we just saw right now. 48, 55, and then 25, 7 comes from our table. 138 is basically you added all the authentic. 178, you added all the deceptive. 181 here, this 181 is when you added all the negative tones. 103 is when you added all the neutral tones. And 32 was when we added the positive tones. Now, some of you might be wondering, what's this numbers at the bottom? Like we worked this last week. Now, if you go this 181 times 138, 181 times 138, divided by the whole total, which is 316, that's going to give me this value. Pretty cool, huh? Now, you're wondering, where does this 18.03 here comes? Okay, for this one, the whole row is 32. The whole column is 178. So this one you go 32 times 178 divided by 316, which is the whole total. And that's how they got those. Okay, so this is something that we worked with last week. So I gave you guys the tables. And then even on the tables at the bottom, we see our chi-squared value, our degrees of freedom, and our p-value. Okay, now here, find the sample proportion of negative tone stories that are deceptive. Okay, so I'm looking at negative tone. So I'm looking at the negatives that are deceptive. Oh, actually, I can see that from up here. Remember, my whole total here, if I add all my negative tones, is 181. And I'm looking at negative tones, the percentage of negative tones that are deceptive. Well, there were 100 deceptive stories, right? I'm looking at my negative tones. I'm looking at these values. And 181 is all together. There's 116 that were deceptive. There's 181 altogether. So let me just go here, and I'm gonna go 116 divided by 181. Now I'm gonna just divide this. My answer, it says rounded to 3 decimal places as needed. Now this is basically the percentage, but notice on the question, it doesn't say find a percentage. It says find a sample proportion. So leave it as a decimal. Don't switch it back to percent. Your percentage rounded to 3 decimal places. So 116 divided by 181 rounded to 3 decimal places is going to give me 0.641. As a percentage, I know it looks like 64%. Okay, my next question. Find a sample proportion of neutral stories that are deceptive. Okay, so now let's see my neutral stories here. So neutral tone, I'm looking at these values. As a matter of fact, I'm gonna put a here, my total here is 103. Right, 48 plus 55. There's 103 neutral tone stories. So how many of these were deceptive? Well, 55 of them were deceptive. How many were there altogether? 103. So let me come here and I'm gonna say 55 divided by 103, rounded to 3 decimal places. So I'm gonna call this 0.534. Remember, I'm asking for the sample proportion. So basically I'm asking for as a decimal. Don't switch it back to percentage. Percentage is 53%, but I'm looking at this as a decimal, so 0.534. Now, on my third question here, find a sample proportion of positive news stories that are deceptive. So from the positive tone, there were 7 deceptive stories. So 7. Divide this. There were a total of 32 positive tones. So 32. Now 7 divided by 32, rounded to 3 decimal places. My answer is going to be 0.219. As a percentage, this basically rounds up to 22%, but I'm leaving it as a decimal, 0.219. Now, Some of you might be wondering, the 181, 103, 32. Looking at our table here, where did those come from? 181, basically I added those two values. 103, I added 48 plus 55. And then the 32, because I added 25 over 7. I mean 25 plus 7. Now, I could have added those, or I could have just seen that the table here. These are these values. 181 is 65 plus 116. It added these values. So I could have used this table to begin with. Okay, it's up to you. Which table do you use? Now, 3 questions that I have here. Does it appear that the proportion of news stories that are deceptive depends on story tone? Okay. So for those that were negative tone, about 64% of them were deceptive. For those that had neutral tone, about 53% of them were deceptive. And those that were positive tone, about 22% of them were deceptive. Do you see a significant difference? The big one is 64% and the small one is 22%. Do you see a significance in those? In my case, I do. So this the period, the proportion of news stories are deceptive depends on story tone. I'm gonna say yes. Because the proportions of deceptive stories vary by tone. Right? One of them was 64%, the other one was 22%, and obviously there was a 53%. The differences are the difference between the first two are not that much, but the difference between the big number and the small number, there's a big difference. So we call that a significant difference. Now, for the second question, give the null hypothesis for testing whether the authenticity of the news stories depends on tone. So we're going to say my null hypothesis. Remember, null hypothesis, we write that as H0, or I can just write the word null hypothesis. Now, I want to write authenticity, and tone, and tone are independent. Because I want to test whether or not they are dependent. They depend on each other. But I'm going to say, well, the null hypothesis is that they do not. So we're going to call that independent. Now, using the technology printout, the table that we have, conduct the test at alpha is equal to 0.05. My printout, let me zoom out here. I'm really just going to look at my p-value. My p-value is 0. Okay. Because I'm just going to compare my alpha and my p-value. I know my p-value, it says 0.000. My alpha is 0.05. I see my alpha is bigger than my p-value. So because alpha is bigger than p, I'm going to reject the null hypothesis. So it says use the accompanying technology printout to conduct the test. Alpha is bigger than p, so reject the null hypothesis. Okay, why do I reject it? Because I see that there is sufficient. Every time for us to reject the null hypothesis, we must have sufficient evidence. If I don't reject the null hypothesis because I have insufficient evidence, but I rejecting it, so I have the null hypothesis, there is sufficient evidence that Okay, so for the finish, what were we checking? Authenticity and tone are independent. And I just said we're going to reject that. So I'm going to say that authenticity, okay, they were checking for independent and I said no, I reject that. I'm going to say authenticity depends on tone. Okay, let me zoom out so you guys can see what we did today.